All right, today we're going on a journey. And I mean a real journey, way, way beyond our solar system. We are heading out into the deep cosmos on a hunt for other worlds. And what we're finding out there? Well, it's changing absolutely everything. You know, the entire reason we even bother looking for other planets starts with this one kind of mind-blowing fact. Astronomers have found complex organic molecules. We're talking the literal Legos of life, just clinging to icy dust particles, floating out there between the stars. Which means the ingredients for life aren't some rare, precious thing. They're everywhere. And once you know that, it leads you to a totally new and, frankly, enormous question. It stops being about chemistry and starts being about biology. It's not about the ingredients anymore. It's about the finished meal, right? If the ingredients for the cake are scattered all across the universe, then where are the kitchens? Where are the planets that give all that chemistry a chance to get cooking and make something alive? Now, finding those places isn't just random guesswork. It's a really methodical process, a way of sifting through the cosmos to find the best spots. And this is the playbook for how we do it. It's called the cosmic funnel. Think of it as this brilliant strategy that starts by casting a huge, wide net over billions of stars, and then, step by step, narrows the search down to just a handful of worlds that could change our view of the universe forever. So let's start at the top, the widest part of that funnel. This first step is really all about playing the odds and having a whole lot of patience. Because what we're doing is we're looking for the absolute faintest of shadows, just the briefest little flicker in the light of a star millions of miles away. And that sounds next to impossible, doesn't it? But that is exactly what incredible space telescopes like Kepler and TESS were built to do. They just stare relentlessly at huge patches of the sky, watching hundreds of thousands of stars all at once, just waiting for that tiny, telltale dip in brightness that tells us a planet just passed in front of it. We call that a transit. And using this method, they've already found thousands of potential planets. That dip in starlight, when we plot it out, gives us something that looks like this. It's called a light curve. And that is our very first piece of solid evidence. But it tells us more than just, hey, a planet is here. The depth of that dip is crucial. It tells us how big the planet is. The deeper the dip, the bigger the planet. First piece of the puzzle, locked in. Okay, so we've found a shadow, and we know its size. Great. But now, what is it? Is it a gigantic, puffy ball of gas, like Jupiter? Or is it a small, dense, rocky world, more like our own? To figure that out, we have to put it on a cosmic scale, literally. Here's how it works, and it's so clever. Every single planet, no matter how small, has gravity. And that gravity actually tugs on its parent star, causing the star to wobble just a tiny, tiny bit. By measuring that little wobble, we can actually calculate the planet's mass from light years away. It's just an incredible feat of precision. And this is where it all clicks together. You take the planet's size, which you got from the shadow, and you combine it with its mass, which you got from the wobble. And that gives you its density. And density tells you pretty much everything. If it's really big but doesn't weigh much, it has low density. That's a gas giant. But if it's got a lot of mass packed into a smaller size, high density, well, now you've likely found a solid rocky world, one of those potential kitchens for life. And now we get to the very tip of the funnel. This is where the hunt gets really exciting. We've filtered out all the gas giants, and we're left with a short list of promising rocky worlds. So it's time to call in the superstar, the James Webb Space Telescope. Its mission? To do something that sounds like pure science fiction. Read the air of a distant world. So check this out. As the planet passes in front of its star, a sliver of starlight actually shines through the very edge of its atmosphere. And the different gases in that air absorb very specific colors of light, leaving behind a kind of chemical fingerprint, a barcode that Webb is designed to read. We're on the hunt for things like water vapor and methane, but the potential smoking gun, the one we're all hoping for, is oxygen, a gas that, here on Earth, is almost entirely thanks to life. And this is where the whole story just comes together so perfectly. You realize that the very same organic building blocks we found on that coal dust at the very beginning of our journey are now the exact same things we're searching for in the skies of these new planets. We're trying to see if the basic chemistry of the cosmos managed to become the active biology of a world. Okay, so that's the method, this incredible cosmic funnel. So what has it actually found? Let's pull back and take a look at the results so far. And let me just tell you, the numbers are absolutely staggering. Just look at that. In the early 1990s, we weren't even sure if there were any other planets out there. And now, we're over 6,000 confirmed worlds, with thousands more just waiting for a final check. We are, without a doubt, living in the golden age of planetary discovery. And this galactic census has already given us a huge surprise. We kind of expected to find solar systems that looked like ours, right? Well, it turns out the most common kinds of planets in the galaxy are things like super-Earths and Neptune-like worlds, which are categories of planets we don't even have in our own solar system. It kind of makes you wonder if our home is actually the weird one. And these aren't just numbers on a spreadsheet. They are bizarre, wonderful places. We found things like hot Jupiters that orbit their stars in just a few days. There's a planet so hot and dense, it might be made of diamond. And yes, you're reading that right. There are zombie planets orbiting the dead husk of a star that already exploded. The universe is just way more creative than we ever gave it credit for. So, from those thousands upon thousands of worlds, the funnel has narrowed it all down to this: about 60 planets that we know of right now that are rocky and are orbiting in the habitable zone. That's the sweet spot where temperatures could be just right for liquid water to exist. This is our current, incredibly precious shortlist. But, and this is the really mind-bending part, that shortlist of 60 is just what we found in our own tiny little neighborhood. When scientists take those statistics and apply them to our entire Milky Way galaxy, they estimate there could be 11 billion potentially habitable Earth-sized planets out there. Just let that number wash over you for a second. 11 billion. And look at how fast we've gotten here. In basically a single generation, we've gone from not knowing for sure if any other planets existed at all, to finding thousands of them, to now having the actual technology to study their atmospheres for signs of life. The pace is just, it's breathtaking. Ultimately, every shadow we hunt, every star's wobble we measure, every fingerprint we read from an alien sky, it's all in service of answering one of the deepest questions we can possibly ask. Is the universe just teeming with life, ready to pop up wherever it gets a chance? Or are we an unbelievable, extremely rare miracle? And that really leaves us with the final, biggest thought. The goal of this entire cosmic hunt, this whole grand endeavor, isn't just to find another rock orbiting another star. It's to find a definitive sign of biology somewhere else. So, if we succeed, if we find a world that isn't just habitable, but is actually inhabited, how does that change everything?